Greetings and welcome to my presentation about my experience in project-based internship program by Rakamin and IDX partners. My name is Bramantyo Nandarsiadi from batch May 2026 and I'm going to present my final project, which is a data warehouse. Okay, so little bit about myself is that I am currently attending Masters of Data Science in Monash, and I also have a Bachelor of Management from UGM, and I previously have done project-based internship as a backend developer and data science. And previous to all of that, I have worked as business analyst from PT Solix Technology Indonesia. If you want to know more about me, you can click this portfolio link, which consists of my contact and the project that I have also done in the past. So let's get to the final task, which is a data warehouse. Okay, so the problem is that there is a client that requires a data warehouse. So as a data engineer in IDX partner, my job is to create a data warehouse for a banking client that has three different source format: Excel, CSV, SQL database. And because the scattered data here causes further need for longer extraction and consolidation, which can slows down the report that is being generated. Okay, so now let's get to the actual details. So as previously mentioned before, the banking client has data that's spread across three separate format sources. And the first two sources, the Excel and the CSV file, both contain transaction records with the same column, such as transaction ID, account ID, transaction date, amount, uh, transaction type, and branch ID. So even though they have the same structure, they are stored in different format and may have overlapping or duplicate rows between them. And the third sources is SQL Server Database, which holds 6 tables: the transaction DB for transaction, account for bank account details, customer for customer profiles, and three reference table, which are branch, city, and state, which represent the information. So the challenge here is that all three transaction sources needed to be merged into one unified table with no duplicates. And the customer data needs to be enriched by joining it with the city and state tables to get the full location names. So this slide shows the overall architecture of our solution, which follows the classic ETL pattern, which is extract, transform, and load. So in the extract phase, we pull data from all three previous sources that is mentioned at the top, and we use Python's pandas to turn all of these sources into a data frame. And the next is the transformation sources. So we apply several operations for the transaction data. We merge all three data frames into one, remove any duplicate rows based on the transaction ID. For the customer dimension, we join the customer table with the city and state tables to get the full city and state names, and we convert all relevant text columns to uppercase as required by the client. And for the loading phase, we write the clean and transform data into our new data warehouse, which runs on SQL Server inside a Docker container. The data warehouse uses a star schema with three dimension tables, which are dimension customers, dimension account, and dimension branch, and one central fact table, which is fact transaction. This fact transaction table references the dimension table through foreign keys, which enforces the data integrity. Okay, so the ETL pipeline is built as 6 separate Python scripts, each with a single responsibility. This modular approach makes it easy to debug, maintain, and extend in the future. So the connection is the foundation. It defines how every other script connects to both databases. It has two types of connection: SQL Alchemy engines for reading and writing data frame, and raw PyODBC connection for executing the DDL statements like create database and create procedure. So because the link for the talent is not working, I was forced to do it on PyODBC. Okay, so for the next is the create data warehouse. So It sets up the data warehouse structure. It creates the data warehouse database if it does not exist yet, and then creates all four tables in the correct order. The order matters because the foreign dependencies, such as dim customer, must exist before dim account, and dim account must exist before fact transaction. Next, the ETL dimension. So it loads all three dimension tables. The most complex part here is the dim customers, which requires the joining of three sources tables together and converting the text columns to uppercase. Next is the ETL facts that handles the trickiest part of the project, merging the three different transaction sources and ensuring no duplicate rows end up in the final table. It uses pandas concat and drop duplicates function for this. Stored procedures creates the two reporting procedures directly into the data warehouse database using raw SQL executed through PyODBC. Finally, the pipeline. So it ties everything together, running a single command, which is, as you know, you just type in Python pipeline.py and then it executes all steps in the correct order. So we created two stored procedures into the data warehouse to give the client quick access to the most common reporting queries. The first one is the daily transaction. It takes two parameters, a start date and an end date, and returns of summary of all transactions within that range group by day. It show in the result shows the date, how many transactions happened that day, and the total amount. This is useful for the client to quickly check daily activity without writing a query themselves. To run it, you simply call exact daily transaction with the start date and end date. So I'm just going to demonstrate how it works here. So I already created the test cases here, so I just have to execute it. This part, and as you can see, there is the daily transaction date, which starts from 18 January 2024 up till 20 January 2024. Okay, and the next stored procedures is balance per customer. It takes customer name as parameter and returns all active accounts belonging to the customer, along with their original balance and their current balance after all transactions are applied. The current balance is calculated using a case when statement is inside a sum deposit transaction add to the balance, while transfer and withdrawals transaction subtract from it. Only accounts with an active status are included in the results. To run it, you call exact balance per customer with the customer name, for example, Shelly. As we want to demonstrate here, the balance per customer name, which is Shelly, is executed. So yeah, here it is. So yeah, both procedures were tested against the expected output, which is shown before. Okay, so the conclusion. So we have created a data warehouse where we can ensure the data is now centralized, clean, and duplicated. The choose stored procedure allow instant reporting without any manual work. For future improvement, the main areas will be adding automated scheduling with airflow, proper error handling, and logging per pipeline step, and data validation before loading to catch quality issues early. So yeah, I think that's all for my presentation. Thank you very much. And the important link will be posted below. And I hope you like this video and don't forget to subscribe.